Hi. Good day. This is the first day of the semester. I hope you enjoy your summer vacation. So this is the class for DOTE, Statistical Analysis for Business Decisions. So section B. So my name is Chu Yu. I am in the B School building. And usually you can reach me by email or by appointment. So I have been teaching this course for past 3 years since I have been here. And I also, like you, 10 years ago, I was in B School. I was an undergraduate in B School, and then I also took this class. And at that moment, it's not one course, it's 2 classes. So this class is divided into 2 semesters, okay? And people complain too difficult, so they combine into 1. So now you're learning 1 semester for 2, okay? So, but of course, we make things a little bit more manageable. So hopefully you will not find that too terrible. Of course, it is well known that this class will be the hardest of all for those who don't do math or those who hate math. This class will be not that easy, but we'll try to make that everyone would find this class to be useful. At least we're going to cover Excel. Okay? So hopefully at least you learn something. Our TA, he did Mang Yang. He decided same as me. If you want to meet him, you schedule appointment. The reasons being that everyone have different schedule, and by setting a fixed office hour, then probably you may not be able to talk to him. So he encouraged you to email him to meet him if you have any question. So for usually the case is like other people, you would be first of the contact would be him, right? If he can't solve it, we will go to me. So he will be the one who will be talking to you. Of course, you're welcome to talk to me anytime if you want to. So same as other classes, we focus on the main thing is to look at the basic statistics. Okay. So later I'll go over a little bit what we're covering to give you an overview of this class. Okay. Hopefully, by then you have a good idea what this class is about. Okay. And the main thing is to make sure that you at least know what is statistics, how the quantitative tool are being used, and we'll learn mainly for the class, we will learn Excel. Okay. For the R and Python, we don't have time to cover in the class. Likely that you will be learning it through the data camp, a website that you can learn by yourself. But that are the topics. And here are the topics that are supposed to cover that is uniform across all the sections. Okay. So whether you're in my section or you're in the other sections, you should learn all of this. At least you know what do they mean. Of course, probably you will not remember all the details, but after this class, suppose when you see these terms, you would be able to say what they are, okay? What use cases, right? But now we have AI and everything, then probably you would not need to remember all the details, but probably you need to know how to use them, okay? That is the main purpose of this course, is not to focus on mathematical derivation, but rather to look at how they're used. Of course, we will give the math or idea behind it, but the main purpose, as you receive from the assignment or exam, reflect the usage of statistics instead of the background behind it. And the reason with the project is also the same. I hope this is okay. Is there any question so far? But of course, I will give you more detail what we are doing, but that will be the topics. So here comes the next is the assessment, I have been using this same type of assessment scheme has been past years. So we will have one final exam, which if it's okay, then I make it open book. It will be on the very last of our semester. Okay. By open book, it means you bring whatever you like except your iPad or laptop, because there have been past concern, people communicate. So any paper you can bring, whatever paper, no limit. Okay. But of course, no sharing paper among your classmates. But otherwise, it will be one single test to test how. It will be very similar to the assignment, similar style, of course, different question, but we will be like that. I mean, so you would, if you know how to do your assignment, you should be able to get a good grade. And participation, as usual, you have to attend classes by default, right? So you should be able to get the most of that if you attend a class. Of course, some of you will do better in terms of classroom interaction, or I was a TA, how you interact with him, so on and so forth. But the participation would not be crucial to determine your grade. Okay. And the homework is to make sure that you would try to understand what's going on, because math, you have to do it. Without doing it, you don't really know what's going on. Okay. I will make you work on some problems, which will be similar to the examples with the lecture slides. So just try to apply it. That would be very standard questions. And I know you guys are very busy, so to encourage you to actually work on it instead of copying, which often have the case, and I make it 80% if you actually do the work, okay? Regardless of right or wrong, as long as the TA think you have done not copying, okay? Wrong or right is fine. It's not exactly the same as the other, then you'll be fine, okay? And the rest of 20% will be the accuracy, okay? So most likely you submit on time and then should be fine. And the last part is projects, which actually I think that is the most crucial part for this class, is to make you work out your own problem. Okay, it's like opening an assignment. You decide what to do, you collect your own data, and then you would be doing that. Okay, you analyze that. Later, I'll upload some past years example, then you will have some idea. Maybe you have time to go over that. That would be you can do it individually, or you can do it in a group. Okay, you can do it by yourself or do it in a group. So it's proportional to the number of people in the group. So if you're one person, you just do one single A4 paper, 2 sides. That's it. Okay, and if 2 persons in a group, then you will be 4 pages. 3 will be 6, so on and so forth. I think that would be maximum. I want to cap to 6 persons, okay, in a team. Okay, if you want more than 6, then ask me. Then we try to see if I allow, right? Otherwise, we have 50 people in the same group. Then I can't give grade, right? So it have to be some cap on the maximum size of the team. But I think 6 would be the decent number. We set the cap. But I mean, of course, if you tell me you have a very big project, you need large number of people, then I would try to see if that's allowed. But usually in the previous years, people used to maybe 1 person, group 2 or 3, up to 4, maybe good. More than 4, maybe usually it's very difficult to communicate. And likely you have some free rider complaint. Since project is you're allowed to do it by your own or do it by group, I don't accept any complaint of free riding. Okay, you don't need to tell me the group until the end of the semester. Okay, so if your teammate is free riding, not doing the work, you just exclude him from the submission. I don't care. Okay, I don't accept any complaint because you can do it by yourself. Okay, no complaint on this. We are not going to entertain any complaint of your group may not doing anything. Okay, if you don't do it, they don't do anything, just drop him. Okay, because we are not collecting your names. Okay, just submit your project at the end. Okay, so there's no complaint on free riding because you can do it by yourself. Okay, we'll go over the projects later. Okay, and the grade will be similar. Okay, there's nothing very special about the grading. For the books, this book, I think, is the same for the rest of the course. You can use it. It's very rather standard, so whatever book you pick on statistics will be fine. Probably now we have AI, then probably I don't think you even need a book anyway. But if you want to buy, that's available in the bookstore. You don't have to buy it. I mean, it's up to you. There's a recommended book also. I think also was used in other class as well. And there's a reference. The bunch of reference that goes a little bit deeper if you want to. Of course, unless you really is that person, probably you don't need to go to these two books. But if you really want to know more, then that would be the books that you can go forward. Okay? In case you're confused, you don't know what's going on, then you can look at these books. But of course, we're talking basic statistics. Whenever in doubt, do AI. That would be the easiest. That would be what I think. Excel, again, now AI, probably you don't need a book, but I just put there in case you need any help. Of course, AI, if I were you, AI would be the first one to consult, second would be TA, okay? Last one would be me. Well, of course, you can ask your classmate as well. And one thing I want to say is R or Python is very useful if you want to do further in data science or data analytics. So I put some books that you would maybe find useful, but of course, we don't cover R and Python in your class, okay? Because of time constraint. Of course, if the end of semester we have time, we can cover it, okay? But there are many website online tutorial that do R or Python, so I think it's okay. We focus on Excel in our class, okay? One thing that often omitted or not covered in basic stat class, which I found that is the most crucial for your success in your business world, is how to present the data, which we don't have time to cover at all. But in this summer, I figured out several textbook that would be very good that I would recommend you to read it if you really want to learn how to present your data, okay? In particular, I would recommend you read this book, The Canific 2015. This is focused on how to present your data in business setting, which I find it to be most crucial for us because we don't have time to do class presentation, right? But you still do projects. So this book, I recommend you to read it. And and the other book that is more recent, this book is also tell you how to do a nice presentation that I would also highly recommend. I read that during the summer. I find it very useful. Hopefully, if you have time, you can try to read them because I figure out that for my business education in CHK for 3 years, the most useful I learned is how to present, right? And at the end of the day, we're all salesmen. Then that would for business school students. So I do recommend you to read these two. I want to cover the class, but the time we have is very limited. So what I can do is to tell you what I find it amazing. You could try to read those when you have time. I mean, of course, at that moment now, probably many of you would be tempted to think that technical is more important, but how to present is also more important, okay? Or even more important than the technical part. Of course, technical part has to be the baseline, but how to present the data is far more important than technical. I don't have time to go over, but I do recommend you to read them, okay? And as standard, the evaluation will be available at the end to let you evaluate me before I evaluate you. Okay? You have the feedback on the end of term. This with the class schedule. I think luckily we just missed one class of mid-autumn. I guess unless we don't have enough time, I think we can just keep it. I mean, we should have time, so we don't need to make up. Unless we figure out that we need to make up, we probably make up by Zoom because I guess everyone was very busy. If I ask you to come back one day, then probably you hate me. So I was student too, right, 10 years ago. So I think if we do really need to do it, we just do it in Zoom. But otherwise, I think we have enough time to cover everything. Okay. So this is the schedule. Let's see if I have anything extra. As I said, for software, we do Excel, okay? Because of the time constraint, we don't have time to R or Python, okay? If you do some makeup classes, then we will cover Python R on those cases, okay? If we have extra time. Or in case we have typhoon coming, we miss some classes, we'll do a makeup class, which is optional. We'll be doing some extra program. So make sure that you don't have to feel bad if you miss it, okay? Just a final reminder that if you do plagiarize and then it will be serious consequence, just to let you know, same as, I think statistics, you don't have to plagiarize, right? Because the math is not complicated. That's syllabus. Is there anything that I can clarify before we proceed into the topics that we are going to cover? Any question? Suggestion? Comment? Okay. If no, then let me go to the document that also in the website that tells you what they're covering. Then you know, have some idea what we are covering for the rest of semester, and you have idea what we're doing. This technical document is rather long, 35 pages. I'm not going to cover page by page, but I'm going to cover the first few pages and let you know what we're doing. Okay. Then I think this technical document tells you what you're going to learn for the whole semester. Okay. By reading that, you have some idea what's going on. Again, this is a technical document, just for people who are interested. I think everyone are very busy anyway. So you can see from the overview, we have 8 different topics, okay, to be covered in the 13 weeks program. So the first 2 weeks that we'll cover topic 1, okay, we'll cover we call descriptive statistics. What does that mean? It means that suppose with data, okay, we are not going to collect any data in this class, okay. Of course, in your project, you may collect the data, okay. The data is available. The first thing we need to do to understand data, right? To understand data, there are many ways, actually covered in the class after the break. The first one will be, we are looking at some numbers that will be representative of the data set, right? We learn something called mean, median, most, those kind of stuff. That will be something we study, right? And then sometimes we learn variance, standard deviation. The number that you learn is statistics, right? We do something that try to summarize the data. That would be the thing, right? So suppose, right, if you want to know a person, you want to know his height, his age, right? When you go to a dating app, right? Look at the person's face, right? Look at how old they are, what's the age, right? How much money he make or she make, right? Then that might be enough, right? That is enough, right? In the dating market, you know how much or she make, right? Whether his house, a car, then done, right? Then that is it, right? The salary or other thing would be important. That's the important number. Or what the main thing you come out of this class you care, right? Probably one thing. It's your grade, it's your GPA, right? That's good to find a job. That's one thing they care. One number. Why? GPA is a summary of what you have done. It's a mean, it's an average, right? That is something to learn. So besides number, the other thing we learn is graph. Of course, we don't have time to go over the graph, but graph is also important to demonstrate the data, right? The data is complicated, right? You can always go to data, but data is so complicated now you can't really go into it easily, right? In the past, Excel, you can look at a table easily, but now with big data, right? Millions of data, the unstructured is very complicated. A lot of data missing, so and so forth, right? And that means that you can't really go to data, okay? Either graph or summary number. So that's the first thing we do, right? We have data, and then we try to see how to get some meaning of it, right? And this is, I think, is the most important part, right? Because you go to business world, right? This first thing to present to your audience. That's the number, right? One number tells, right? Look at the economy. What's the unemployment rate? What's the inflation rate? What's the GDP? That's a number that summarizes what happened, right? Now, the second one topic is about probability, okay? Why we care about probability, right? Because this roll a die, right? Toss a coin is about probability, right? Something random. And why we look at data, how is it related to statistics? You may ask, okay? One of the reason why is because we don't want to look at data by itself, okay? If we have the data for everyone, that's government do, they call census, right? Then we don't need to look at probability. That's the end of story. If I know everyone in Hong Kong, how much they make, I get the average of the data, then I'm done, okay? The problem is, in general, we are not able to observe everything what we want to know. We're only able to observe some of it, okay? And why I can draw conclusion from something that is not the whole picture, right? I look at part of it. Why I can say the whole thing, right? That rely probability. Okay? The probability tells us how likely that I look at a small part of the picture, try to infer a big part, it works out, right? That's probability. Okay, that's why we learn probability and we learn the random variable, all those things require probability. So this is the basics that underline what we're going on for the rest of the semester, right? So if we can look at everything, the class end at topic 1, done. Okay, but we are not. We only can do sampling. We can only look at part of it, right? Then that rely probability. Okay. And there are many ways to define probability. That is a many way, and there's a many rule. That would be the subtopics in topic 2. Okay. And topic 3 will be a second advanced topic or called random variable. Okay. The reason why we need to study random variable is the following. Because to describe the future or uncertain world, which is probability means, right? It's toss a coin, right? And the math can be very complicated. Okay? When you have many coins to toss. Okay? Suppose you toss one coin, it's head or tail, right? Suppose to toss 2 coins, you have head, tail, head, right? Will be 4, right? If you toss 10 coins, how many likely you have? 1,024 to be exact, right? And then you have, suppose you have hundreds of coins. That is huge, very difficult to describe, right? You look at our stock market, we have around thousands of stocks, right? So even just up and down will be very complicated to describe, right? So what we do, how we understand our stock market is what? Hence an index, right? A number that's trying to represent the whole market, right? And we are looking at how this number changes. That's called random variable, right? We try to summarize our uncertain future, a multi-dimensional problem, into a single dimension. And we're able to study that, okay? That's the goal of that. And there are a lot of use cases of random variable because when we reduce a very complicated problem into single number, okay, that we can understand easily. Of course, you may ask, can we understand more than one number? Yes, but not in our class. In this class, we only understand single random variable, okay? Unidimensional, of course. When you learn higher, then you learn multidimensional, okay? So to recap, topic 1, we study how to describe data, okay? And topic 2, we give you a foundation. If we don't observe what we want to study, only part of it, okay? How do you draw conclusion from small to big, okay? And topic 3 is saying that our world is super complicated, right? So we try to reduce our focus on single number. Okay. And then at topic 4, actually tell you, we understand enough the foundation. We tell you how the small picture we try to look at, how it looks like. okay? Because we said at the end of the day, we look at small picture. We do survey, right? We try to talk to some of the people and collect data, right? And then we look at how, depend on who you talk to, right? Then you would get the idea, right? Then we try to see how to do those in the sampling discipline. That's called a sample, right? Suppose I want to know, right, how happy you are the first day of the class for the CK student, right? Of course, if I'm able to, at the railway station, ask everyone, right, then will be good, right? But I don't have enough time. So I do, maybe I ask some of you, right, some of the people in the railway station, then give me the idea, right? By doing so, I'm doing some sampling, okay? And whom I talk to is a random thing, right? It's not something I don't know. Before I do the sampling, I don't know who is going there. Before I talk to the people, I don't know who is there, right? Depending on who is there, will give you the sampling distribution, right? Understand some basic concept. Later you learn called the bell curve. That's the idea. The bell curve, if you learn in the high school, that is what is behind. We'll tell you a most important theorem in statistics. We call central limit theorem, which tells you that if you study something that's nice, it's very useful, you will have a bell curve, the bell. And that is the idea behind is topic 4, okay? That will be the idea, the bell curve. Okay? Probably you will forget everything in this class. One thing you remember is bell curve. Okay? And then topic 5 is estimation. Okay? Since we know the bell curve, right? What we actually drawn from the data, the small picture, we want to try to predict what in the big picture. How to do it nicely is called estimation. Right? So that's what you see recently in the election in the US, right? And US have about 0.3 billion people, right? And look at how they do the survey, ask people who you're going to vote, right? Either Trump or the other lady, okay? And in that case, how many people they ask? Usually not more than 1,000, okay? 1,000 or 2,000, compared to 300 million people in the US, right? And you ask, okay, why it works? That tells you how can do estimation. Okay. So that's very often, right? You're marketing, right? You're doing estimation as well, right? Because you're go into a particular market, you try to develop the market, you want to know the taste, right? What you do is to do a test in some small market and try to infer, right? It's estimation. You do, for those of you who do accounting, you do audit, is also estimation. Why? You go to the site, right? You go to the warehouse to check the inventory, right? You don't really check every single inventory, right? You try to pick up something from row number 1, shelf number 1, and go on randomly, right? You try to do estimation, right? You don't do full check, right? That's estimation, right? Again, it's a small picture, data, try to infer what's going on in the large picture. Okay, that is what statistics is about. And number 6 is called hypothesis testing, which is again is the very useful technique they will be using. It's like the judge, the judge, but based on statistics. Okay, and in the court, right? The judge will present some data, right? And when the data is beyond reasonable doubt, the judge will take it, right? Statistics is a randomness, okay? So just like you go to see a doctor, right? The doctor will do some diagnosis and ask you to do some chemical or physical tests, right? And you will test several times, right? Before the doctor has confirmed what's going on, right? So that is hypothesis testing, right? You have to see multiple indicator and try to check whether this is valid, this would not. Because again, we're looking at small picture, try to guess what's going on in the big one, right? But instead of guessing some number, we're trying to test certain things. What are testing? Suppose on the test, where standard case is whether men make more money than women, or women make more money than men, or they're fair or not. That will be, we're testing the hypothesis. Or we look at, is the economy going up or going down, right? Because it depends on who you ask, can be random, right? Suppose I want to ask, are you happy? Okay. And if someone come to this class and ask you, then you will not be happy because you're listening statistics, right? And if you go to the class where you listen music class, wine appreciation, music appreciation, then everyone's very happy, right? Then depend on what you draw, right? So that's very important. And now come to the very last two topics. It's called analysis variance and regression, okay? And these tools are, I think, the most single useful tools when you go further. And indeed, you can consider what people do for statistics or for all the advanced classes are basically regression and ANOVA. What are they? These are what we call cause and effect. We want to study whether something causes something, whether they're different, right? For example, what are the difference between these two? Okay, it's called X and Y. It's X cause Y, okay? And if X, okay, later you will learn if something categorical is not a number, okay, we got ANOVA. For example, we want to see does manager A in Hong Kong Island, McDonald manager, a fast food manager, McDonald B on Kowloon Peninsula, say suppose. You want to see whether these two managers are doing equally well or someone better than other. They do ANOVA. Or you can do even further. There are different stores in Hong Kong. Well, your fast food manager, you want to see different chain, are they doing differently or the same? Okay, you do ANOVA. Okay, X and Y, X is discrete, X is something different, it's not a number. You want to see different places, and then use ANOVA, right? Or you can try to see if different gender or different sexes or different, say in CHK, we have different colleges. If different colleges, people are same or different, right? And in my old days, there are only 4 colleges, right? NA, CC, UC, or SAW, okay? And because of the location of SAW, people think people in the SAW are more laid back, right? I don't know if that's still true now because this is 10 years ago. Now maybe other school method is similar. But if you run ANOVA, then probably you notice people in SAW have happier, lower GPA, but happier, okay? And CC people are more competitive because they are more scholarship and so forth. And then they have to attend weekly meetings, so on and so forth, right? So on. But I don't know, but that will be use case ANOVA. And regression. Regression is simply, as I said, X cause Y, right? In economics or business, the most interesting or most used case is, or that you'll be interested, is called the Mincer equation. And X is education and Y is income. What we want to know is whether you study make a difference, right? And why you spend time here, right? Listening to statistics, which is very boring, which I agree. Why? Why is it listen to me, right? Why don't you go home and look at TikTok, right? Or play games or whatever, right? Instead of sitting here. Why? I mean, of course, you do it because it requires class, but if don't require, then probably not here. Why? And you want to see is another year of education is going to help you or not, right? And in general, yes, right? So far we learn is the best return for investment is education, right? Usually an additional year of education, actually the return is 8%. Okay, so it's better than whatever investment that you would have already up to the stage of undergraduate. Okay, master less so and PhD less so, but you would be not regret of having education. Okay, And of course, these views are challenged recently in many social media in China, who said the end of the college education is unemployment or not very good. But anyway, so far from historical evidence, learning or studying or investing in your own human capital is always rewarding. Okay, but that is rely on regression. We try to understand how X cos Y, right? Of course, to establish how X cos Y is very complicated. Okay, in our class, we can only just call correlation, not causality, which will be emphasized in this class. We just saw how X change with Y, okay? Not X lead to Y. To establish how X lead to Y require you to study a Ph.D. Unfortunately, I mean, you have to study the whole Ph.D. to understand how to establish in the right way how X cos Y. But for undergraduate, you can learn how X change with Y. When X changes, Y changes. One reason why it's very difficult, why you can't establish X cos Y from the data, because there may be something called Z that behind, right? For example, more education lead to high income, right? But it may forget that there may be tiger mom behind beating you if you don't study, and tiger mom behind you to get a good job, right? So if you forget the Z, which is tiger mom, they're done, right? That will be something that is omitted there. That's for example. There are many reasons that you have to study a PhD or master program in order to understand how to establish X cos Y. But we just touch a little bit and see how X cos Y. Okay. For science, that's easy, right? Because control X. For experiment, that's okay. But for business or for social science, it will be difficult because the environment is not controlled. Suppose a marketing manager, you reduce the price of product, say, okay, you increase your sales, okay? Does it conclude that lower the price, increase your sales, and then you want to recommend your boss to do discount? No, not necessarily, because the environment is not fixed, right? Because it may be the case that your competitor is raising the price or doing some stupid thing, right? It doesn't conclude that automatically that's the right thing. You have to go further to infer what's going on, okay? But that is a little bit advanced, but that is give you what we're doing here, okay? So to summarize what we're doing the whole semester. First, we tell you, we give you data. You can tell me how can you describe it in a presentable business manner, right? Because no one is going to read your data, right? The manager is too busy, okay? They just read your summary report. That is what I asked you to do 2 pages for your project. That's it. I don't need the detail, okay? I just need 2 pages. And then for topic 2, 3, and 4 is give you the foundation of the math or understanding why you can draw conclusion from small number of data to draw a whole picture in the world, right? You're only able to look at small thing, but you are trying to infer what's going on in the big picture, okay? So you have some modeling behind, right? How to infer from that, right? Right? For example, right? If you, right, there's a case, right? If you tell some people, you go to a building and you go to buy the badminton equipment, right? And whether you believe this guy is buying equipment or doing something else in that building, right? Probably don't know this joke, but that's fine. After that, we learn 4 different tools, okay, of statistics. Okay, estimation is based on data. You try to estimate what's going on in the world, right? Actually, look at the unemployment rate, look at GDP, look at all those are estimation, right? Because no one have whole data of the whole market. Okay? And hypothesis testing is the way that you try to use the data to see what we know is right or wrong, right? Suppose your manager want to say, okay, look at some data, the market has changed. Do we need to have a new design of the product? Or do we need to change strategy of marketing, right? So and so forth. Okay, that is called hypothesis testing. And the last 2 are looking at cause and effect, whether X lead to Y. Okay. So that would be the main goal of this course. Is there any question? I'm not going to go over everything because we'll learn it all the way around, but that is the idea. I'm pretty sure that it's very complicated. Okay. For the main topic, you can see I will try to highlight to make you feel a little better. You can see many things already covered in junior school or in the secondary school or M1 or M2 calculus. And in fact, if you learn M1 or M2, 75% already covered. Okay, 75%. If you actually come from associate degree, actually my class is even easier than what you covered. And of course, past year, always the students say, "Oh, professor, I have studied this in the associate degree, but I forget everything." Normal, okay? So, although many things have been covered, you can see everything is covered already. You can see there's something not covered, but 75% already covered in our thing. Property is something new, is ANOVA and regression. These two are less likely to be covered in your, if you don't do the advanced math class. Okay, so a very long document. I'm not going to go over that. For the remaining, I think I have only 3 minutes left before the break. I quickly want to show you one thing which I'll upload later. Is I used the last year one. Do I have that? Sorry, I don't have that. Oh, yes. Probably I upload that as well. Just some example of the project that have been done in the past to give you an idea what's going on in the projects. So I just show you one because of time constraint. I will put the rest on the website so you can take a look what have been done in the last year. So this is the project that done by, I just randomly pick up one project. It's looking at use statistics to understand tennis. Okay. As you can see, it's 2-person project. Their page limit is 4, but they do 3 only, but that's fine. Okay. As I said, business well, the shorter the better. Okay. It's better not to use up everything, right? So what this project is about, probably you will see they're a tennis player, and then they want to see look at professional matches to try to draw meaningful conclusion. Okay. So what they do is look at, okay, what's the rate, depends on the venue, how likely you get double fault or ace. If you do play tennis, probably you know what they mean, but don't ask me. I don't play tennis, but okay. And they do some, this is the data, right? That's topic 1 is about, right? Doing some summary statistics to present the data in an easier presentable way, right? And then next will be, they do hypothesis testing, okay? And they will try to conclude whether double fault and ace are different between different landscape. That's what they do. Okay. Don't worry, I upload this on the website. Don't need to take picture. Don't need to take picture. Okay, at least. Okay. And this is what they do, as I said, that the bell curve there always, right? That's how you describe it. Okay. And then they do different type of tests, depend on different assumption there. Here they do double fault, right? And here do ace, so that the 2 different cases. Okay. And then they do ANOVA, as I said. Okay. And they do a different thing depending on the height, right? Whether people taller and shorter is different. Okay. So remember this cause and effect, right? Whether people are taller or shorter change the outcome, right? And whether the chord change the outcome, and whether there's 2 are interact, right? Is taller people perform differently at different type of chords. Okay, so this will be the example, and they draw a conclusion. Okay? It's very standard. I will later put that on the web to let you see it. And I pick another one. Okay, very quickly because I don't want to ruin your break. Just allow me 1 more minute. So this one look at Netflix, and at that time they want to look at Disney Plus. Okay, they use different way. The technique that I focus on at the end of the last 4 topic to understand what's going on. Okay, they want to see whether Generation Z have different taste towards Netflix or Disney Plus, right? So you can see the process very nice because at the very beginning, first 3 sentences tell you what they're doing. Okay, and as you can see, these are 4 pages, right? Because they have 2 person. Okay, and then the methodology. What they do, this thing nice is they have survey, right? So you can collect data by themselves. You're not required to do primary data, but you can collect somewhere else, or you can use data that have been used. Okay, like the tennis case. But this one is they go to the library, I think library, or the Facebook, ask your friend to fill in, and then understand what's going on there. Okay, and then they have some understanding, male or female, and again the t-table, and there's some study and the ANOVA, and do some regression, some graph, and so on and so forth. Right? You can see a lot of bell curve. So that would be what I'm expecting. That would be something you do for a project. You can do it on your own or do it in a group. Okay. So I guess, is there any question before break? No? Then enjoy the break. We'll resume at 2:20, 2:30. Okay. Yeah, have a break. 標嗰叫咩名？
叫咩咧？即係疫情時候用嘅。係。
叫咩？
我都唔記得，好耐冇。
綠色嗰個 website
係要雙重認證嗰個
LM 係啊，嗰個叫咩？叫咩啊？C 哦，要明白。 So I guess usually I would try to get how well you're doing in the class. So maybe you can feel free to fill in if you want to have something to say. And then before we continue, in the meantime, I walk around to see if any question because many of you are very shy. So you're welcome to write something there. If you don't want to say it out, it's anonymous. So you can write there, then you can let me know what's going on there. But I walk around if you're in a question, but I guess that's the first class, probably you don't, but I think only 7 questions. You can quickly try to tell me what's going on. Just to make sure that you familiarize yourself with the U reply system. You reply. Because I used to use this one to get some feedback from you guys and see how fast I'm going, how slow I'm going. Because no one tried to tell me anyway. This is the only way I can get feedback from you too. Okay, maybe it's good to take a look how we are doing. So in case you want to fill in, the last chance to fill in, it's just intend for me to know how we're doing because it's large class. I cannot possibly track everyone how well you're going, but you're really welcome to say something. I see you record the Zoom. Yes, I will upload this class on the web if there's no technical problem. Usually there's no, but there will be. The whole class will be uploaded in case you want to go back. Yes. Yes, same to you. Hope you have a lot of money. How are you? I'm fine, thanks. Not available. Okay. Good day. Okay, that's good. Learn about stats. You have no idea on statistics. Statistics is a number that try to represent data. Is something technically it means the random variable. It's an unknown number try to represent the state of the world. Okay, just like Hang Seng Index is to what is a number at the end of today's market is a statistics. Okay. That's the meaning. No. Thank you. Oh, thanks. I just get a new T-shirt because the old one is very bad. So there's a new one. Thank you. What's this? How to copy that? Oh. It's a cake play. Let's see. Oops. Let's see what's going on. Hopefully it's not pornography. Good. Okay, I think it's okay. Everyone knows this. In case you can watch, if you want to watch, you can go look at Never Give You Up. Okay. Next Tuesday. Oh, okay. So this is the statement about probability, right? It said next Tuesday, 100% will be typhoon set number 10. Okay, that someone claim it. So it's a hypothesis testing, right? So we can see whether it's right or wrong. Okay. I want to pass. I guess so far for this class, I had never failed anyone yet. So you can try to challenge me to do it. I think if you do all your homework and then attend exam, right, then you should not fail, right? But if you don't do your homework, you don't do the exam, then you will fail automatically, right? You do the project, everything. If you do it, okay, then you're able to pass, okay? The grade depend on you, not on me, right? So hope that you'll be okay. And as I said, this class is about math. It's more about some calculations, some understanding what's going on, what tool to use and when and how, rather than math. Because in our exam, it's open book, right? So you just know where to get the information. That should be fine. I don't get it, sorry. Thank you. For trading, I guess you mean financial trading. Indeed, before I come to CHK come back, I was in Singapore, then where I taught a class about trading that rely on different statistics. And you learn technical analysis, look at the past trend, the wave theory. These are all depend on statistics. Yeah, there is a lot of people who do that. The algo trading, machine AI trading are all based on this. A lot. Yeah, it's fun. If you know it's fun, but otherwise it's pretty dry. But the use is fun, right? How to use it. And the math behind is rather boring for many of you. Nice professor, I don't know, but host Sam Philo. What's his host Sam? What's that? Can it? Oh, hi Sam. Okay, it's the semester start. Yeah, give me good grade, please. My response is, so you can look to the TA, look for me, look at AI, we try to help you. Okay. But it's not that easy. I don't know. That's okay. let's look at the number 2. Oh, okay. We have one person who don't know what day today is. Today is Monday, not Friday. Okay. So this statistics, right? Very nice. The graph tells us what's going on, right? This is actually a good case to see the bar graph tell us very clearly what's going on there, right? The number below, right? Just the bar by bar is very clear. So you can see we use statistics already. Of course, I guess this guy is playing not really serious, but okay. Now you can see even for this question, how's the weather? We don't have a uniform unanimity, right? We don't have a uniform response to that. I understand people will say windy or cloudy, but rainy, I don't know. But must be rainy in his heart or her heart, so probably not very happy. But hopefully we got sunny after this class. Stat. I know. Okay. Bell curve, yeah, that's good. Cause and effect. Cause outline. The syllabus, none. Yeah, the course requirement. We better do math. What happened? Work hard. Yeah, group project thing. Yeah, the math not hard. Yeah, that's good. Let's see. So far it's okay, not too fast. That's okay. Someone think I'm too fast. Okay, I try to slow down a little bit, but I don't know what to slow down. But I try to see. You will see the same type of question I ask every class. So you used to this set of rule reply. Okay, and so far it's okay. Okay, Manchester United. Okay, for those who don't know Chinese, there's an advertising for the city of Hong Kong, which is 4 stops away from here. Okay, so I guess they want to say if you want to go for the master program, try to do the City U. But since I'm here, I recommend you to do it here if you want to. Yeah, my response is him again. So I try. Why the tomato bush? Okay, that's a good one because usually we see a lot of not so healthy jokes thrown around. But that's okay. As I said, healthy, so it's a semi-healthy. That's okay. Oh, this is a joke. This is a joke in Chinese. Those who don't Chinese, I'm sorry, but they're saying that there's a captain who surname is Law, but every call him Captain Law. But Captain Law just mean the engine thing. Friday off, trust me, brah. Okay, I trust you, but we don't have class on Friday, so sorry. Too healthy. The lecture chair so bad. I don't know. It has been like this since I was 20 years ago. So yeah, maybe it's a little bit aging, but I enjoy sleeping on this chair. It's a pretty good one. Although there's no the headset there, but it's a good rest. I guess someone want to throw me again, but I'm not gonna click it. I ate KFC for lunch, but where KFC? I think it's Satin, I guess. I hope you enjoy the chicken. Nothing special. My life is a joke. Then please share. No, okay, that's fine. I hope that's okay. If there's no more question, then I will go to start our lecture. If there any question that I can answer, as I said, the lecture is record. So if you have any question, you can always fall back. And all the past 3 years, all the lecture will be similar. You can always look back. If you want to look ahead, also the same. So of course, probably you will notice each year I change a slightly different, but almost all the content will be the same. So if in any case you want to do a forward study, you can always do that without any issue. So the first topic is descriptive statistics. So as I said, you just describe what you have, the data you have, okay? And why we care about this is the first thing you want to know, right? We have data download or data collected, you know what's going on. And this is the basic thing you want to do, right? What it here is we add nothing to the data. There's no new thing from the data. Everything is from the data, what's going on in the data, okay? And from the topic 2 onward, we try to draw something from the data, not pure on data. We try to draw from the information from the data. We try to draw what's going on in the big picture. Okay? How now we are only confined data. We're not going to create new knowledge. Okay? We just try to make sense of data. Okay? Is that clear? There's nothing new created. Okay? Everything is existing, but we'll try to clean it up. Okay? So here is the standard classical dichotomy or two-way classification of statistics. So as I said in the beginning of the class, it used to be, for this class, used to be a 2-semester sequence. In the first semester, we learned the descriptive statistics, which represent the first 4 topics in this class. Okay, and that is not to create anything new. Okay, and the second half of the semester, also in the past 20 years ago, is what called inference statistics. It's trying to use the data to infer. To infer means look at the hit, try to say something that we don't have data on. It's infer, okay? And that's the idea, okay? And we want to, now what we focus on is to give a clear picture, either a visual one and the other one is numerical one. For the visual, as I said, is the most important thing because people are attracted to colors, shapes, rather than numbers. Okay. And as I said, we don't have time to go over those. I recommend you to read those 2 books that I said in the syllabus, which you should read it if you want to learn how to put what we learned in this class to a higher level. Of course, if you learn more and more classes in statistics, then you will learn progressively, slowly on your own. But if you want to learn right away, those skills, you should read those books I mentioned. Okay? And in the class time, which limited, we focus on the numerical representation, which will be the mean, the variance, the kurtosis, skewness, all the data that you can generate from Excel. Okay? So our class is more or less based on the tools that you can use in Excel, and those things you can do it with Excel. Okay, of course, you can do it more advanced software R and Python without no problem, but our study are all revolving about Excel. So everything you do can be done in Excel quickly. And Excel is still the single most used package that in business world. And probably some of you want to know Python R, and probably many of you will know in the future version of Excel, I think Python will be R, or I forgot, one of them will be incorporated there, because it used to be B.B.A, but now they're going to take it out because B.B.A is super slow. But that would be something that we'll be working on. So have some terminology there here is important. It's called the data. The data has 2 different types. One is called categorical. The other is called numeric. Okay? I focus on numeric first because it's the easiest you can imagine. Numeric, the first one is discrete. It's like the count data. Okay? How many girlfriends or boyfriends you have? 0, 1, 2, or 3, or 0.5, right? Right? Or 1.2, someone like that, right? Right? When 0.5 means is like cloudy, not very clear, right? It's because, right? Relationship is 2-way, right? If 1-way is called 0.5 or 0.1, right? It's unclear, right? And continuous, right, is something that anything in between is also allowed, right? Say temperature, stock price, while continuous, say temperature now is, say, I don't know, 35, right? Let's check. And then if I have 36, right, anything between 35 and 36 are missable, that's continuous, right? There's no gap between data, it's a continuous. Okay. And you may ask why we need to distinguish these two. The reason later you learn in topic 4, random variable, okay? How to model a randomness of a number, it crucially depends is discrete or continuous, and use different tools. For discrete, we can use our standard tools that we learn in high school. Standard algebra, no problem. For continuous, we need calculus. Don't worry, we're not going to cover calculus, but we need to let you know there's some tools that we need to work on it in order to derive certain property, okay? And that's why there's some distinction. And why we need that is how we do the modeling, right? Because we use this probability to model the future. Whether you think it's discrete or continuous, we make things different. And you would choose the two that fit the best, right? Because nothing in the world is truly continuous or truly discrete, right? At some point, there may be something else, right? If you learn quantum mechanics, at some point there may be quantum, right? But some people said at the end, the string theory there is a continuous. But anyway, I'm not going to talk about the discussion, the philosophy, but I mean, depend on what tool they're doing to do, we will do this too. And the first type is called categorical data. Actually, also you often have this data, like gender, right? Man, woman, or more than 100 different types of gender, right? Races also different, right? And they are not order. You can assign number there, right? You can make female 1, male 0, or other way around, but the number has no meaning, right? Just a number, right? How do you go to school, right? I go to school by bus, by train, by MRT, by whatever, right? You can put number to there, but number has no meaning there. Okay? So the other is ordinal. Ordinal is often the number that also you see often, right? When we go to website, you buy stuff, look at the rating, 5 star, 4 star, 3 star, 2 star, 1 star, right? And obviously, 5 is better than 4, 4 is better than 3, so on and so forth, right? But the difference between star has no meaning, right? 4 star, better than 3 star, right? But 5 star is way better than 4 star, right? So it is completely very different, right? Just like on liking scale, right? At the end of the semester, you're going to rate me, right, by a scale of 6, right? And then each jump is different, right? 4 and 5, 5 and 6, the jump is not the same. Okay, so that's called ordinal, just number. We give a number to this order, but the order by itself, the difference is no meaning, right? And that is actually a problem of how we do analysis. Be very careful. Order the data is different from the numerical data. Okay, this is a little bit advanced. Okay, because we don't have time. In our class, we mostly focus on discrete or continuous with nominal. The ordinal data, if you want to study it, actually require another class because it's very complicated. Because as I said, 5 is 1 star higher than 3 before, 4 is 1 star bigger than 3. But the difference is not exactly the same, right? So that is if you want to study that, there will be require a whole course to study in detail what they are, okay? But the problem is a lot of people try to pretend, okay, the number has meaning. Why? Later you will see if you apply average to ordinal data, it's misleading because you can add and subtract by ordinal data because the number just means bigger the number the better. You can't really add something. You can't add apple plus orange, right? They're different things. Just mean higher, right? You can't say this apple, I give bigger apple is 4, small apple is 3, right? Add together you cannot add it, right? You can add the number, the price is addable, right? But you can really add something that is not addable, right? So when you look at the website, right, people give you the rating, average star, people give is 3 or 4.3 or 4.99 or 4.9. Doesn't mean anything because average have to add and dy later you will see, right? But add has to be meaningful. You have to add. You can't add something that is not addable. Okay? Of course, you will say, okay, there will be still stay something, but average, later you will see, has some meaning that if you apply to ordinal data, has some problem. You may ask, okay, in that case, what would be the appropriate? You should look at the median. That would be a much better measure. Okay. Anyway, this is just the caveat that try to let you know what kind of tool can be applied to which data. Okay. Later I will emphasize some misuse of statistics. Okay. And this is only slide that I will tell you how you work with the graphics. Okay. For the rest, you should check it by yourself and use your business instinct to decide which kind of the graph to represent data the best. Okay, because in this class I don't have time to tell you those. And you can see if you have categorical discrete, you should use bar chart or pie chart. Sorry, scam call. But and if continuous is histogram or polygon or bar chart. And later, if you want to show how X and Y are related, you have scatter plot and line plot. Okay? And these are just some basic suggestions that what you can do. Okay, I recommend you read the 2 books that I said in the course outline to learn when to use what chart. That would be a very useful one. Okay, and I'm not going to talk about that. Okay, so hope that you learn how to do it and you learn which chart to use in your project. Right? Please use the appropriate chart. Okay, to represent data. Okay, Excel is very easy, right? You can easily see which chart to be used. Maybe I open Excel. Okay, in case you don't know, but I guess everyone would know it, right? Suppose you have some data, you go to the chart. Yeah, there's an insert here, and there's a chart there. Okay, you can decide what chart to plot on, and probably you can ask what kind of chart that suits the best. Okay, so that would be something that you will do, but if time we can go for them. But for the moment, we just not going to cover on this. Okay. Now, here comes to the thing that we will focus on for the rest of the topic. Okay, is the key measure on the data. Okay, you usually have 3 different aspects you want to tell people your data. Okay, and the first one is called central tendency. Central tendency is a number that if your boss tell you what do you have, you give that number. The number is either mean, median, or mode. It's a single number that tells us what's going on there. Okay, what we have usually the case, right? The median income, right? The 中位数, the number that represent the data. Okay, it's the middle, right? The mean will be adding up and divided by total number of them, right? And the mode is the most frequent one. I'll define formula later. But these are the 3 numbers that will cause central tendency. Okay, and as I said, different data determine which one you can use, which one you can't use, which one is more appropriate. Okay, and we will learn in detail. Hopefully by today we will learn 3 of them. And the second number that the boss want to know is how good is this number you have. You give me the average, give the median, give the mode. How useful it is, right? If the data is very condensed, very close to each other, right? Then the mean, the median, or mode you give me is very good. Okay, it's a very good, accurate measure. We want to see how accurate is your mean, median, or mode. Then comes what we call the dispersion measure, how spread the data is. The more spread, of course, means that the central tendency measure is not so good. Okay, and probably you would know is called the variance, standard deviation, range. Those kind of data we'll go into detail probably on Wednesday. Okay, and these are 2. I think you learned it in your high school. Okay, but I We'll assume everyone forget about anything after the summer. Okay. In case not the case, let me know. You know it, then I just skip. Okay. Make my life easier. But I assume everyone has absolutely zero knowledge. We start from the beginning. Okay. It's like primary school or even kindergarten. Okay. And the last two is slightly little bit more challenging. Is what we call the shape or the data. How it looks like. The shape means I try to plot the graph. Data will be a graph, the histogram, or the bar chart. How it looks like. Okay. Is it skewed? Is it symmetric? Does it mean there? Is it the same number of people on the left and the right? Okay. And we want to know why we care, because that is something very important, right? Look at the income data. Is it more people on the left or middle on the right? Is it a lot of rich people or a lot of poor people? Right? That's important. Or in the marketing application, right? You want to care about average number, not average amount they want to spend, right? Is it a lot of people willing to spend a lot? In that case, you can sell premium product. Or there's actually most people are spending on a lot of people are not willing to pay. Then you're going to sell a discount product, right? It really depends on your strategy, depends on the shape, the skewness. Skew left or skew right? We'll give more detail. And here is called the kurtosis, the next one. The kurtosis is looking at the bell, the shape of the graph. Is it the tail, the two sides, is it fat or not? Okay. Is it the extremely fat thing at the end? And why we care about that? It's related to finance or risk management. Okay. If things have high kurtosis, that means that there are a lot possible of catastrophic risk, right? If you do insurance company, you care about kurtosis a lot, because that means that because in insurance company, in general, they make money when things go normal, right? But when earthquake comes in or disaster come in, there are huge loss, right? If you don't careful enough about kurtosis, then you lose money, right? And that's what happened in 2008 when they do the financial crisis, right? Many of you may know one of the reasons of financial crisis in 2008 in US is because of the excessive people are trading on algorithm trading designed by mathematicians who assume nicely distributed data, forget about the kurtosis. And when things happen, okay, the credit crunch, and people keep selling crazy, and the kurtosis thing happen, extreme thing happen, then all the trading algorithm collapse. Okay. So now you can see after this financial crisis, people care a lot about the tail risk, right? Or whether we risk the tail, extraordinary thing, that's called the kurtosis. Okay. But I will give one more definition later. But just give you an idea for the rest of this topic, mainly three things. And this is the main three things we study for this topic. Okay. Is that okay? Is that clear what we're doing? Okay. For the remaining 15 minutes, I'll try to cover the mean, median, mode, and happy. We will see you on Wednesday. Okay? Not done yet. I mean, after 15 minutes. Okay? So as I said, briefing, mean, median, mode. I'm pretty sure that you know them, but I try to give you what a caveat, what is so special thing about those. Okay? Let's get started. Mean. Before we do that, with some notation. Sorry, there's some notation here. I think some notation will help us to go ahead. Quickly notation. Okay. Because it's a college class, so we need to do some symbol, and to do some symbol means make our life a little bit easier to describe. Okay. And usually we'll call number observation n. Okay. And the date observation will be denoted by the first observation will be x sub 1, second will be x sub 2, and up to x sub n. Okay. And we'll use shorthand notation called summation sign, the sigma. Sigma I sum 1 to n of xi is this adding up. Okay. That is called the sigma notation. The reason we want to do that is make our slide manageable. Otherwise, our slide explode. Later you will see. But this sigma notation we will see very often when we go to topic 3 or topic 4 and up to so on. Okay. This make our life easier. And then a called function called floor or ceiling. Actually, you can see in Excel later. Will be very useful. Rundown is like a L, okay, to L there. is just to get the integer part. Okay, 3.1 is 3, 3.99 is 3, 4.1 is 4. Get the integer. And run ceiling is run up means that you got the smallest integer that's larger than what we have. Okay, 3.1 is 4, 3.99 is 4. Okay, and 4.01 is 5. Okay, so I hope that's clear what's going on there. And I think this last line, two more slides, sorry. It's called the sorted data. Sorted data by default is sorting from the smallest to the highest. X1 is smallest, Xn is highest. And the frequency is the number that, how many number that has same value. Okay, suppose my data is 1, 2, 2, 3. The frequency of 1 is 1. Frequency of 2 is 2. Frequency of 3 is 1. Is that clear? It's tallying, it's counting how many of them. Okay. And another definition is called the relative frequency, which means that it divided by n. How many percentage of them, right? So that means that a 50% of the data is 2, right? 25% is 1. 25% is 3. Okay. So that, I think you learned it in the primary school. Okay? And this is the data that you often present if your data is manageable, right? You remember the example in the break about the tennis case, right? The tennis example they give you is the frequency table, right? Telling you that different number, right? Different cases, you give the frequency, right? And this is called contingent table, two-way table. That's we often use it. Is different category, male and female. The category pass or fail, and the number tells you how many of them, right? And these are the marginals, right? I think this 2 is here, and then this 2 is here. Is that clear? What we are doing? We have to use this, right? Oh, reverse. Yeah, this add this here, this add this here, this add to this one, this add to this one, add this to this one, this to this. Is that clear? I mean, I think this you already done it a long time back, but just to start with some notation there. Okay, now let's start with the mean. Okay, mean, everyone learned it in the primary school. By definition, very simple. Just add what you have together and divide the hundred of them. Okay. So the first thing you have to know is you do some add. To remind you, you can only add where you can add. Right? It's meaningful to add. Right? If not meaningful, that this means nothing. Okay. So that's why you can only add for numerical data. Ordinal data, you should not do it. Categorical data has no meaning. Okay. So I have to be very careful. You can only add. Okay. Okay. And we call this notation X bar. Okay. Now, we give you the meaning of the mean. I think that's the most important thing is you to know what does that mean. Okay. Why it's called central tendency. Okay. It's very simple. Is every central tendency measure is something in the middle. What's the middle there? It's middle by distance. By distance, it means that look at all the data you have. Mean is the location where you look at things on the right, from the left, look at the distance. Some of this on the left and something on the right are the same. Okay? Graphically, like this. Look at this diagram. Okay? I have 4 numbers: x1, x2, x3, x4. Okay? The mean is the location, x bar, where the distance to the left is the red one. This on the right, the blue one, is exactly 0. Okay? You can imagine this is a seesaw, all right? They just move your x bar such that the left and right are equalized. That means that it's a middle by distance. Okay? That means what? you're actually doing subtraction. Distance has to be meaningful for this mean to be useful. That's why I said you can't apply this to ordinal data, which usually people make a mistake. Okay, so you can only apply to things you can do. A distance makes sense, right? If distance doesn't make sense, what's the meaning of you subtract, right? So the data has to be subtractable for things you can do mean. Okay, just to make sure you know what you're doing. Okay, of course, your boss asks you to do mean, you don't argue with him, right? Of course, if he really want me, just do mean. But you know by heart that his or her is not right, okay? Or it's not really meaningful because between distance, right? The distance has no meaning. What's the meaning of that? Okay. Yes. Okay. So that's why if you do math, it just means the sum of all the distance is 0 because left is positive. So left is negative and right is positive. Left is positive and right is negative, right? So they cancel out. And here the next thing is if we replace everything by the value of mean, nothing changes. Okay. So that is the meaning of the mean. I hope it's clear right now. Okay. Now to give you an example, which I'm pretty much sure everyone know how to do it, right? Example 1, data 1, 2, 3, 4, 5. What's the average of those? Just add up there by 5. Nothing new there. And second is 1, 2, 3, 4, 50. Is add up divided by 5. And why I care about that? What's the moral story here? You can see if I just change one number, the last number, okay? Change to 5 to 50. Then what you see is the mean just jump from 3 to 12. Okay? 3 is fine. 3 is in the middle somewhat, right? But 12, what does that mean? 12 is nowhere close to 1, 2, 3, 4. Very far away, right? So mean is not a good measure if your data has an outlier, right? Outlier, things can change differently, right? You look at how much people make in Hong Kong, a lot. And everyone will think we are poor, right? Because there's so many rich people in this world, at least in Hong Kong, right? And that's why we don't talk about mean when we talk about average income. We talk about median, right? Because median later you will see doesn't affected by outlier, okay? But when you talk about this, you will see this skew a lot, okay? And outlier here is so far away, right? Maybe the 50 is the right number, okay? Or the 50 is a typo. You collect the number, you do it wrongly. So mean is not very robust, okay? So that's why in the real world, when you have a large number of data, we don't really use the mean simply. We do some cleaning. Or just to remind you the meaning of the color in my slides, okay? So the blue one, the purple one is something that you should know, okay? The black one is something I advise you to know, but you can forget, there's no problem. Just for you to understand what's going on there. The technical, you just safely ignore them. There's no problem in your exam, okay? The purple one is the thing that you have to remember. This is technical just for fun or just for your knowledge, okay? And the green one is you should know very well by heart because this will be in your exam or in your assignment. That's something I expect you to do how to operate, okay? The green one is operation, okay? And the black one, the gray one is something that I would expect you to try to learn it. And of course, if you don't fully follow, that's fine. You can come back a few years later, you can see the slide and probably you know better, okay? Don't really worry. So here, as I said, outlier is thing that you actually have the data and you would do it, okay? Something is called the two ways you can handle data with outlier, okay? Either you go trimming, okay? You take away those numbers, okay? Suppose you want to take the income of Hong Kong people, then what you do is take away Lee Ka-shing, take away Richard Lee. They're too rich to be included in the data to be meaningful, right? So they exclude them. So go trimming, take away. Say like this, take away, become 1, 2, 3, 4, done. The other one is also we're using called Windsorizing. Okay, the rinserizing means that you just say replace the outlier by the percentile. Okay, just replace it, just cut off. Say you have 100 people. Okay, slower to largest. When you have 96, 97, 98, 99, 100, these number are replaced by the 95 guy. Okay, and the lowest 1, 2, 3, 4 are replaced by the value number 5. Okay, in that case, they call rinserizing. And rinserizing in this case, I would be rinserizing the 50 by 4. So the mean will be rinserized one, will be much better. Okay, these are the tools that actually we apply in the practice. Okay, as I said, the technical slides, as we say technical here. So just for you to know, you learn it in the future when you apply it. Okay, I don't expect you to know this, right? So what I expect you is to know this definition and how to calculate mean, okay, which you should know. Okay. So maybe I don't have much time. So let me end with this weighted average, and then that's done. I don't want to take just 2 minutes left. So in general, the average is adding everything up divided by how many of them. That is the implicit assumption that every observation is same. Okay, but in general, it's not the case, right? You take many classes. Okay, you have general education, you have PE classes, you have many things, right? Among many classes you take this semester, my class is the most important. Why? Because my class is 4 credits. Okay, so that's why your GPA, this class get an A is more important than other class. Okay, so pay attention. Okay, if you don't pay attention, you lose more. Okay, so it's the weighted average. It means that every observation you have the weight WI, you multiply by that and divide by sum of the weights. Okay, so that's what you do to calculate GPA. You calculate the moving average, like the price. You put higher weight to recent prices when you do technical trading, right? Recent prices carry more weight than further distant history, right? Or your portfolio return is weighted by the weighted average of investment, right? The weighting of you put more money in this investment, you weigh more. Or Hang Seng Index, right? Hang Seng Index is weighted by capitalization, right? When HSBC move, the whole market move because HSBC is one of the largest, right? Or 10 cents, they move, right? So that would be the thing. Okay. So just final example, then I'm done. So this example, I have 1, 2, 3, 4, 5. The weighting is 6, 3, 2, 3, 2. If simple mean, it's just 3. But if weighted mean, it becomes 2.5. Why? Because the lowest observation one have much higher weight than the others. Okay. So my time is up. I see you on Wednesday. Just end here. If you have a question, I'm staying behind to answer.